First off, some definitions you should remember from previous math courses. A relation is any set of ordered pairs that you can put on the grid. For example, a scatter plot, a line, a parabola, a circle. These are all relations. You can graph it, it's a relation. A function is a type of relation. It's a relation where each value of the independent variable corresponds with only one value of the dependent variable. So you can see some examples. These are all functions. Every x value maps to only one y value. These are not functions. If you notice, one x value maps to two different y values here. You can tell if something is a function using what's called the vertical line test. If you imagine a vertical line moving from side to side, you should only ever have one point on that line at any x value. You can see that these fail. 2 points, 2 points, 2 points. Next, the domain of a function. The domain is the set of all values of the independent variable of a relation, usually the x-coordinates. And range is the set of all values of the dependent variable, usually the y-coordinate, of a relation. Here we've got some examples. This is a line, y equals mx plus b, slope of 3 and a y-intercept of -2. If you recall, a line goes on forever in either direction. Negative infinity that way, positive infinity that way, negative infinity that way, positive infinity that way. So we say that the domain is all real numbers. X is an element of all real numbers, and the range is y is an element of all real numbers, which is to say x can be anything and y can be anything. Here we've got a quadratic. It's got a minimum at -5. The domain, x is an element of all real numbers. X goes to positive infinity, negative infinity, but y on the other hand, because we have a minimum, y is greater than or equal to -5. And lastly, a circle. You can see that this circle only goes from -5 to 5 this way, and -5 to 5 that way. So the domain is x has to be between -5 and 5, and y has to be between -5 and +5. Well, let's talk about transformations of functions. This should also be reviewed, hopefully. We can take any function f and transform it in the following ways. Some a value put in front of the function results in a vertical stretch of the entire function by a factor of a. Some k value inside the brackets there will result in a horizontal stretch of your function by a factor of 1 over k. A d value inside the brackets with your x will result in a horizontal translation. Now watch out, a minus sign in there is to the right and a plus sign in there is to the left, the opposite of what we expect. And lastly, our c value is a vertical translation up and down. That one does exactly what you expect it to do. A positive value results in an upward shift, and a negative value results in a downward shift. For example, a quadratic equation. So we've taken a parabola, the graph of x squared, and we've transformed it using 4 transformations. 1, 2, 3, and 4. This is your a value. It's -2. The negative tells you that it's been reflected along the x-axis. Your positive y values have become negative, and your negative y values have become positive. The 2 tells you that it's been vertically stretched by a factor of 2. All your y values get multiplied by 2, and as a result, your graph is 2 times longer. This +1 inside the brackets tells you that your whole graph has been shifted 1 unit to the left. Again, plus sign means to the left, minus sign means to the right. And this -4 at the end tells you you've taken the parent graph x squared and shifted it down 4 units. And now the concept of an inverse function. We intuitively know what an inverse function is. The inverse of addition is subtraction, of multiplication is division, and so on. So what an inverse does is it takes your input values, turns them into output values, takes your output values, turns them into input values. We can think of inverse functions in 2 different ways, graphically and algebraically. Graphically, what happens is each of the coordinates swap. Your x-coordinates become your y-coordinates, and y-coordinates become your x-coordinates. For example, here's a line. I started with this line here that goes from the point -3, 3, and ends over here at 4, -1. The inverse function is simply the line that connects -1, 4 to 3, -3. My x-coordinate became my y-coordinate became my x-coordinate, same thing there. This is f inverse, or the inverse of the initial function f. Algebraically, what happens, we also swap x and y. To find the equation of an inverse function, take your function, swap the x and y variables, and simply isolate for y again. 2 examples, beginning with this linear equation. Step 1, swap your x and y variables, and then I isolated for y. Another example, I began with the square root function, swap my x and y variables, and you can see that I isolated for my y variable. We have to be careful in this example. We began with the square root function and ended with a quadratic function. But you'll notice this is only half of a parabola, and I want my answer to also be half of a parabola. So I state x can only be greater than or equal to 0. Otherwise, I'd have this other half, which isn't true. We only had half of a parabola over here, and the inverse is just that 1/2.